Hello, and welcome to Late Night Amp Repair with Wayne. um, I have some time tonight to get into a newer repair. This is one of the ones that was on the waiting list. If you're on the list, I promise you I'll get to your amp. Again, I do this as a hobby. It's not a business, so I can't have everybody send me all their amps. Like, I probably have enough to fill my entire basement, at least half my basement, with boxes of amps. That's how many requests I have right now. But if you're on the list, I promise I'm doing my best to try and get to you. So this is one that we're gonna knock off the list tonight. So let's get into it. Hopefully my camera is cooperating, and it seems to be. So this is a RSA-500. This is just an external amp made by Klipsch. I've never worked on one of these before, so it was kind of cool popping this open and getting a peek inside to see what these are all about. The first thing that I noticed right away is this power supply is just a typical supply that Klipsch used this in I think they're RSWs. Let's see if my cord will reach without yanking my head off. I have a couple of these on my shelf. We're just going to look at one real quick. I'm just going to grab one. This is my my testing version, but it's a pretty similar design. This is off of one of their higher powered subs because it's got 4 transistors on the input, or MOSFETs. So it should be pretty straightforward. Some subtle differences between the two. This is geared more for console style. I don't know why they made the box this big. There's just a ton of wasted space in there. I'm guessing they use these on multiple models. I'm not really sure. This should be a 500 watt amp, somewhere around there. This is the 1000 watt power supply. This is the 500 watt, and I have one of these somewhere buried in my parts pile. So I have worked on these before. Not this specific unit here, but I've worked on this section before. So I pulled the cover off. The customer had his name and address on the cover, so I figured I better remove that before I start the video. And I haven't done anything to it yet. So you're seeing basically what I'm seeing, just minus the cover. Okay, so this is a Bash designed amp. I'm looking for a manufacturing date on it, and here's a serial number. So this looks like maybe 2018, December of 2018. Maybe? I know it wouldn't be 1972. 1218 is the first 4 numbers on the serial, so 2018 sounds a little bit new for this. I'm not sure. It'd be nice if they had, dates on the actual boards, which they don't. Anyways, it's going to need a recap. This board for sure. And there's not really a whole lot of caps on the other boards, so depending on how hard it is to get to them, I'm going to try and just recap everything. Make this thing like brand new. It's, it shouldn't be that much extra work once we get into it and get started. So we'll start with the power supply. That's always the most important part. If I can get the connectors out. There we go. They did not want to cooperate. And I think those have the locking style. These locking style? Yes, they were, but they actually came out. Interesting. So these connectors do have the locking tabs on them. There's somebody from Russia making comments again. I hate when people post in the comment section on the live stream and they just put a link and then they don't even say nothing. Like, get the hell out of here. This is my stream, not yours. Put your spam and your garbage somewhere else. Anyways, yeah, we're gonna get this power supply out. Get this bad boy back up and running. and then get it back on its way home. I'm sure this has been on the list for a while, even though it was high on the list. There's no easy way to work on this. I almost need another set of hands. And I'm definitely going to move my coffee because I'm going to spill it and then I'm going to be upset. I need my coffee tonight, even though I've already had like 10 cups. Alright, so step one is just going to be to get this power supply out, which it's already not cooperating. I gotta love these plastic screws. Alright. Let's try this one. I will say they did not use a ton of glue on here, and this one has some silicone on it, so maybe this is a higher end unit. I am not sure. But either way, it's in need of a little TLC and some love, so we will do that today. Give it some love and bring it back to life. As long as I can get the screws out. Oh yeah, again, I don't really understand why they made the chassis on this so big. It's a whole lot of space really not used. I mean, you could fit 3 of these things in there. Make it a stereo amp or 2.1. I don't know what they were thinking when they did this. Maybe they weren't. So they have 3 standard screws and 3 screws into plastic standoffs. Couldn't have just took the extra 22 cents and used standoffs on everything. That would make too much sense. They gotta make it difficult on me. And then this one does not want to spin. Alright, so the power supply should be free now. We will start with that, and I will get this beast out of the way. It is a rather large unit for what it is. It takes up my whole bench. Alright, make sure that's safe, and let's get a look here and see what's going on. So, oh, alright. They did use silicone in here, which is nice, but they did not use silicone around the caps. Granted, they didn't use a lot of that gnarly glue either, so that's a good thing. There's a few spots in here that I'm concerned about. We have a blown up Carly cap, which is fairly common on these. So we're going to recap the whole power supply input section. I am going to assume that probably the FETs are okay. Generally, the failures on these are cap related. Uh-oh, the wife's up. I gotta mute you, hold on. Alright, sorry about that. I had a visit from the dog and the wife. FETs tested good. They do not appear to be shorted. So we're going to start and we're going to remove the big caps and get in here. We're going to pull the Carlies out. Those got to go. And then we'll do a little bit of recapping on the rest of it. Now, I don't really know what this board is. This must be the power supply control board. No, that's here. I don't know what this is. This is new to me. This looks like a typical bash board. This looks like a typical control board for this. This is different though. This is foreign to me. That must be for the preamp circuits maybe, some sort of power supply. I don't know. I guess we'll find out. So, I did find my solder sucker tip after extensive searching. It was inside of a cup. Dog's running around downstairs having a blast. Snowing like crazy outside, so the dog's been cooped up. Alright, heating up the solder sucker. Everything on there appears to be in pretty good shape. Not sure why the film cap failed. They usually fail due to heat, but there's not a lot of heat around there from what I can see. Just bad luck, I guess. I do need to get this silicone trimmed out. Might as well just do that now while we're heating up. Just trim it so we can pull the bridge away. And there's one cap behind there that absolutely has to be replaced. That's probably going to be bad. Usually is. This vintage of amps, they have usually like 3 problems. Problem 1 is the glue, and it gets around this resistor and causes shorts. Problem 2, the film caps blow. And then problem 3 is there's an electrolytic cap down here by this control board, and it's usually out of tolerance, and that causes the power supply to not turn on. So we could have maybe one or all of these issues, but let's do a recap first, because we're not going to really know what's going on until we get some good parts in there. So we're going to start with that. It's so nice having my soldering tip back. These big tank caps are generally good. I don't know why my solder sucker always seems to be clogged. Does not love me. The big caps are generally good, but you know, we're going to do a replacement on pretty much everything. And they're coming out quite nicely. I don't know how you know, expensive these units are, or if this is like their high end, or don't really know much about it. But what I do know is we're going to get it fixed, and it's going to be like brand new. Alright, let's get the other big cap out. They should all be the same on this. This is 680, so that's a new value. This one's probably 1,000. Nope, that one's 470. Close that. So we should have all the caps here. So far, anyways. It's quiet in the chat tonight. I need more subscribers. So if you happen to watch this video, you definitely need to like and subscribe, and then come hang out while I'm working on these. Then I have somebody that I can interact and talk to, so I don't get bored. Alright, this goop we're going to try and rip out. It's just a big blob of silicone. And if you've ever worked with silicone, you know how easy it's going to be to get that out of here. Especially a huge blob like this. I'm glad they use silicone though, and not like the garbage glue. I'll take that as like a partial win. But we got to get the cap out, so we got to at least remove some of it. The smaller Carleys by the power supply will also be replaced. The other ones, like the ones over here and the ones on the EMC filter, don't really seem to cause any issues. I really have yet to see those fail, unless, like, usually what happens is I'll be cleaning up this glue and I'm using the hot air on there. I need some light. There we go, that's a little better. But usually I'm cleaning up this glue, and when I'm cleaning up this glue, I'm using heat, and I get too much heat by these caps over here, and then they deteriorate and start to cause problems. That's mainly the issue that I have. Oh, I spilled my water. Nope, that was alcohol. Spilled my alcohol. I didn't spill my coffee, I spilled my alcohol. Not the good alcohol either. The kind you can't drink. Luckily that will just probably give me a buzz and clean up the desk a little bit. I know the desk is dirty. Not terrible, but dirty enough. Alright. Water. We need some water. I would much rather spill alcohol than water. I'm going to try not to lose the large desoldering tip, since that is like my main component. I made some mess over here. Clean up my desk just to destroy it again. Oh well. Alright, so yeah, you can see this cap here. I mean, that's in pretty bad shape. It's just completely burned and blistered, and that's a bad day. That's got to go. It's got to be repaired. So I'm thinking we'll do that. I'm looking on the board. There's a little bit of glue down in here. I think I might try to remove. Yeah, there's some gnarly glue back by the transformer. So we'll pick some of that out, and then we'll hop through and do the rest of these caps, and then we'll fire it up and see if we get our voltage back. I'm going to say we will. I think this amp wants to be back in service, so The replacement tip is heating up, and I'm just picking some of the glue in here real fast. Just while I got a minute and have my razor out. This glue is, it's about to turn into the nasty stuff. It's not quite there yet, but it was close. I apologize if I just made your tweeters go out with blowing into the mic. Alright, so let's take out the burn cap. So bad it blew it in half. That's a really gnarly failure. Let's take a look at that. Oh yeah. Yep. So it's a 105K, and that's going to go right in the garbage. And I should have that film capacitor's medium. I hope I have a 105. And of course the writing on them is so small I can't see what the heck it says. 105, that's what, one microfarad? I should know that, but I don't. One oh five. Yeah, 105 is 1 microfarad, and K is the voltage on there. So, I need my magnifying glass, which I don't have readily available. I need my microscope, which is also not hooked up yet. So I'm going to have to rely on my eyes that really can't see anything right now. And this is 1 microfarad. I'm just making sure there's not a decimal on there. We'll measure it too, just to be sure. How's that? Make sure it's good and make sure that it is the right value. Should show up at 1 or close to 1. So where are we at? 1.02. That's a good one. Alright. So that will be our... Oh wow, look at that. Just burned itself into the board. That's kind of gross and gnarly. It leaked all its film fluid everywhere. We're going to go right into the garbage with that one. I don't want that all over my desk. There's like some sticky, gnarly nastiness on there, so that's going to get a little bit of alcohol treatment. Whatever dielectric was used in there, it was leaking out and made the board a little bit gnarly. Luckily it didn't damage the board. And also, lucky it didn't catch on fire either. Most of these have safety features built into them, but you never know. Anything is possible. Alright, good as new. Let's get the 2 smaller ones out. Those should be 0.1 microfarad. They should come out fairly easily. Lead-free makes everything a nightmare. Especially when my soldering tips are constantly clogging. I think that's happening because the filter inside my handheld here is starting to go bad. It's probably time for a new filter. Yeah, I think the filter has seen its last days. Well, we'll see if we can get through this. I do have some spares. I don't really want to change it right now. Let's see how far we get. These ones look like they're still good. I'm going to let them all up just to make life a little bit easier. You do have to be careful with these boards too. They're better quality, but they still will lift pads. Alright, here's the two films. Now we have one electrolytic that needs to come out, and we should be in good shape. Alright, the electrolytic, of course it has bent leads. I'm gonna just snip this one off. I don't want to deal with bent leads right now, since I have access. We're just gonna cut it out. Cut and rip. See if I can tear a giant wad of this silicone out. I don't know why they use so much silicone in there. That is a huge blob. I'm gonna cut some of it out. You really don't need that much silicone in there. I mean, they use more in here than they do in the actual subwoofer amps, which is kind of crazy. I don't think this thing is exposed to the vibrations that a woofer amp is, but maybe, I don't know. Well, either way, get in there and just cut some of this crap out. Doesn't have to be spotless because this is silicone, so it's not really going to damage anything. It's probably some form of RTV. Little loose chunks, you can just kind of pick them or peel them out. But you don't have to get it all out. RTV is okay. Yeah, and it is some sort of silicone because it's got that slippery feeling on my fingers. Alright. Let's pull these cap legs out now. It's, you know, the reason I'm doing the cap this way is just because the leads were bent, and I really don't want to deal with damage to any of the through holes. If I don't have to. Sometimes you have to, but I'm hoping today we don't have to. Alright, so that one electrolytic, I know I smashed it a little bit. Let's see what it reads anyways. This one is generally bad. It'll be hard to get the gator clips on there with the leads chopped down. So it's reading about half. So I'm sure squeezing it didn't help, but most likely that cap is out of spec anyways. Let's just look at the film ones. These should be 0.1. Yeah, so they're still good, but I'm going to replace them anyways just because this whole area is sometimes suspect. It's not worth messing around with over a cap that's only, a few cents to replace. So we'll put some good film caps back in, keep the heat under control, and one electrolytic. And I'm going to guess that the amp is going to start up after that. We'll try it. See what else we can find on there. I don't see any burn marks. Actually, I'm going to do the full recap before we plug it in and try it. That way we make sure that everything is good. I need to get my coffee out of the way there. Susan Owen. I don't know what you're linking in there. Stop posting links in my channel. Denied. Alright. Film cap 1 is in. And I'm just using the larger iron to solder them in just so I know I'm getting plenty of heat down in there. I don't want cold solder joints. This does not have very large ground planes on it, but still doesn't hurt to hit them with a little bit of heat. Now I'm talking the legs, not the actual device. You don't want to put a ton of heat on the device. Alright, one electrolytic, 47 at 50 volts. We're using Nichicon UPS series, 105C rated. It's my pretty much go-to cap for everything. They work very well. It's a tier 1 quality cap, so you can be assured you're not getting garbage put back in there. I don't use any Amazon or eBay caps or anything like that. Everything that's going in here is straight from DigiKey. 100% genuine parts. I don't deal with garbage. So this guy here, this resistor, I like to just yank on him. The reason I do that is I like the legs to be straight. So you can hit it with the pliers, squeeze it a little bit. I like to have them standing up straight. That way you don't risk, with the glue it's more important, but you don't risk shorting out to the board when they're laying flat like that. It's not a total deal breaker, but just something to consider. Alright, there's our new 680s. Now the old ones I was surprised to see, these are 105C rated. I don't know who MHC is. I'll have to look that up. If they're a quality cap and they test good, I might save them for like a hobby project or something. Won't ever go back into an amp, but I might be able to do something with it. So LGW Nichicons are going back in. good quality caps. These guys are the most expensive part of the repair. Depending on what brand you use, yeah, some of these caps can be, you know, $8 to $10 a piece or more. But if you want your equipment to last and you want it to sound good, you got to use quality parts. You can't put garbage in there. If you take garbage out, you definitely shouldn't put garbage back in. Alright, primary side is complete. Got a brand new recap on that. Now we got to do the secondary side. This is just littered with a bunch of little filtering caps. I'm going to see if I can pick the glue out of there first. Got some glue. There you can see it right down in there by the edge of the transformer. And it's just touching the legs of a diode and a resistor. So I'm going to just try and chip some of that out or break it out of there. If I have to, I'll get the heat out. This stuff is a little bit crusty, so we might need to. Anywhere the glue touches component legs, it's got to come out. You can't just leave it in there and let it contact, you know, anything really. It will cause problems, and you will definitely be seeing the amp again if you know, you're the one repairing it and you don't pull this glue out of here. It's a pain because it's hard to get out sometimes, but it's the right thing to do. Just take the glue out. I apologize, the view is a little bit difficult here, but I just want to get this crap out. It actually is kind of a tight reach. You gotta be careful too, you don't want to damage the board. So you kind of gotta push and pick a little bit and use some judgment. You don't want to make sure you're not stabbing into the board, not damaging any components. Dental picks, unfortunately, are really the only tools that you can use to pop that crap out of there. So there's a spot on the bottom of this board here. I see something. I'm hoping that that's just glue that is or transformer varnish that's stripped down. I'm looking, you know, there is other glues that's down here and on the board, but I don't think any of it is in a critical spot. I'm looking at the traces. I want to make sure I didn't damage any traces down inside. You can see the glue is beginning to become conductive, but the board still looks pretty good. You can cheat, and the light does help. You know, if you need to look through the board and... Is there any... No, there is no easy way to remove the silicone. The silicone sticks to everything. But the silicone can stay. The silicone really isn't bad. It's this yellow glue that it starts off like rubbery and gummy, and then it turns into this like crispy, flaky stuff. I don't, you know, it gets hard and brittle, and then after it gets hard and brittle, it starts turning this brown color, and then it becomes conductive. So silicone can stay. Like this blob of silicone that's in between this board and the clamp for the MOSFETs, that's gonna stay right in there. It won't hurt anything. If you do have to get that out, you got to take a razor blade and slice it carefully. But anywhere the glue has turned brown or is touching the legs of components on the board, it has to come out. So there's a diode and a resistor down in here. I can zoom in. Let me zoom in. See if we can focus. I can see a little better. So yeah, there's a resistor and a diode, and then there was a thing of glue that was in between the transformer and the two legs there. So we got the glue out. And that just makes sure that, you know, we're not going to have to worry about shorting down the road on those two legs. And everything else looks pretty good. A little bit of solder mask popped off, but that won't hurt anything. Now the glue up here, even though it's turning brown and gnarly, you can leave that stay, because it's the wires on these are coated. It's enameled wire, and it's on a plastic part of the cap, so it's not touching the board, it's not touching anything. It might turn brown because of the heat, but it's not going to cause any shorts. So that can stay. I'm not worried about that. Next, we have to continue the recapping. Yeah, I see no other glue that really concerns me. I see a lot of caps that concern me, though. Luckily, the leads on some of these are a little longer. I'm really hoping that I don't have any through holes come out. I'm going to kind of baby this a little bit, just because some of these areas are really hard to reach. 47 at 50. So they're I mean, these are cheap caps, Junzel caps. I'm just going to measure a couple of them to see what is good and not good. So yeah, so these caps in this thing are failing. This is supposed to be 47, and I'm only reading 22. So definitely a full recap on this unit, no matter what. And I expected that it was going to have cap-related issues, so I was mentally prepared. But hopefully we'll get the caps in there, get them soldered in, and hopefully this thing will sing. Never played with one of these before, so I'm kind of excited to try it out. It's interesting to find out that the components that are used inside it are really no different than any of the other Klipsch thing. I mean, there's a few changes on this, but I wouldn't be surprised if this exact board was used in one of the subs and they just changed a few components on it. I'm not sure if this is a subwoofer amp or if it's just a general purpose. I'll have to look at the crossover and see what they have set up on here. Alright, one cap in. There's one little one in there. I think that's part of the on-off circuit that's going to be really hard to get to. bent leads are going to drive me absolutely bananas on this thing. And unfortunately, I can't get in there to trim them off because they're all kind of buried behind something. 10 microfarads, 63 volts. I don't think I have that one. I have 50, I have 100. We're going to have to go with 100 on that bad boy. 63, that's a very uncommon value. I'm not going to delay this thing 2 weeks though, just looking for a part. One cap. It's still a good one. Can always go up in voltage though. Can replace a 63 with a 100, but I wouldn't replace a 63 with a 50. I don't know how much voltage is going through there, but it's going to get a 100 for now. $63. The only thing I don't like about replacing caps with the higher rated voltage is the next guy that goes to repair this is going to look at that and be like, oh, it's supposed to be 100 volt. So I don't necessarily like not using the right values, but sometimes you just don't have a choice. And you know, to delay a repair 2 weeks just for one capacitor, that's nutty. This thing is just not sucking worth a damn today. I said I wasn't going to change the filter, but it's making a liar out of me. I think I am going to change this filter because I can't deal with clogging every 10 minutes. Alright, new filter it is. I got to repack and rebuild all these filters anyways. I have a pile of them starting. Luckily I do keep spares ready because that is one of those parts that do get used a little bit more frequently. Brand new and ready for service. I hate using my new ones though because they are hard to get and not cheap. I have suction though. That's the most important part. This little cap in here was completely folded over. Hopefully that wasn't creating any problems, but it definitely was sitting weird inside the housing. I'm trying to be done. I'm not ripping these things out of the board. I'm like kind of wiggling them and hoping they come out nicely. So this is 2.2 at 50 volts. And it's a little baby one. I don't have baby ones, but I got bigger ones. I'm guessing this is, no, it's 105C rated. I'm surprised. Very small cap. Let me double check that value again. 2.2 microfarad, 50 volts. This one's a little bigger, but it'll last way longer. I see why they used a short one, because it wouldn't normally fit underneath this transformer here. So I understand. Check our polarity, make sure it's in right. And again, I apologize. This area is kind of hard to get into and see. But we'll give an overview once I get some more of these parts in there. Make sure we get a good solder joint. And this one's going to get bent because it is touching that coil that's in there. So there's a little transistor. We're going to move him out of the way, and then we're going to bend this cap just so it's free. We're not going to go crazy with it. Just make sure it's not going to ever touch this coil that's here. So you can see I just took the cap and just did a little kicked it to the side. Again, the wiggle method, you know, when I'm shaking the part while I'm pulling the solder off, it really helps clear the holes to try and minimize the risk of pulling one of those pads out. I'm going to measure this 220. I want to see how close to inspect this one is. Not bad. That's within 20%. 220 at 25 volts. I got a few of these. That one will work. Maybe this one. I have a few different body sizes of some of these. Still a UPS series, but try and match it up. Making sure my polarities are good. I triple check that. I hate putting caps in backwards. I've done it many times and it just creates a lot of headaches because if you don't find it right away, you guarantee the amp's going to be coming back. And my motto is I don't ever want to see it again. Once I work on it once, I never want to see it again. Don't call me and tell me it ain't working. Unless it's really not working, then you can call me, but hopefully it doesn't get to that point. I try to do my best to make sure that when these things go out my door, everything in them is in working order. You know, granted, you know, sometimes weird things happen or I miss something. Can strive for perfection, but it's very rarely achieved. There's another comment on here. Remove. Sorry, foreign person, but no links in my chat unless you tell me what they are for. I don't want somebody clicking on a link and having it go to like a porno site or something. Alright. Almost done with the power supply. Just a little bit more to go. I do like working on these power supplies because the two heat sinks make a wonderful kickstand. So when I flip this plate over, it sits nice and flat and makes it easy to work on. Alright, let's see, we got 4 more caps to go. I'm going to load up each one of these, regardless whether they need it or not, with leaded solder, just to make it a little bit easier. 100 at 25 volts. So far we only had the one cap that was a little bit weird. That 63 volter. Pretty uncommon. I'm going to save him. Maybe I'll order just a couple of those and throw them in with the others. Just not something I typically use. Alright. I think both of these are 100s at 25. These caps are for the low voltage power supply. The plus minus 15 volts. That's what drives the op amps. I did get my signal generator repaired. So, you know how I was saying don't buy parts off of Amazon? That's not always the case. Sometimes it's okay to do that. And I had the spare down here. Well, either way, I don't need to get into it. I bought a replacement LCD for my function generator on Amazon. I paid $8 and I got 2 of them, so I'm back in business. Not that I wasn't before, but I really like my function generator. So it is nice to have that working again. And as I showed in my video on, I think, Friday, you can use like a cell phone or any computer, any audio source really, it doesn't matter. As long as you can generate a sine wave and control the frequency. So there's multiple ways to do it. I just prefer to have a discrete device, and I've been really happy with the way that this cheap little function generator works. So I'm hesitant to give up on it. And luckily when I plugged it into 12 volts instead of 5, it only blew out the screen. It didn't take out any of the other circuits or anything with it, which I'm thoroughly surprised by. I'm guessing that they don't use a voltage regulator or anything on the screen. The power from the screen is just directly from the power supply. Alright, we got 2 more. And we can snip all the leads and fire this thing up and test it. That's what I'm excited for. I'm going to guess these are 47s, because the other 2 are 100s. There's a little piece of dust in there. Let's get that out. I'm guessing these are also part of the lower voltage supply. I think these are the 2 regulators here. Yeah. So these 2 are regulators, and then these are the diodes and the 2 FETs that control the main output power, and that's from the dashboard. So this must be a switching supply for the plus minus 15. I don't know. I'll have to look. It's some sort of power supply, I can tell you that. What type of supply it is, that I might not be able to tell you. So yeah, 47 as expected. Let's test this one. 47. Let's see if it's within spec. The other 2 weren't. Oh jeez, that's really bad. So this is supposed to be 47 microfarad. It says 47 on there. There's no period or decimal. I'm going to hook this up again. 4.4. That is completely shot. That is why you need to recap this old equipment. Or really any Klipsch equipment, because they use garbage capacitors. Sorry, Klipsch. That's the truth. Please don't send me like a cease and desist because of that. Alright, last one. We'll test this one too, just to see if it's just an issue with all the 47s. So you can't just go in and fix the ones that you think are bad. You got to fix them all. There's no way to test these really in circuit. Just get in there and get them out, and this one will probably be good because the other one was toasted. No, this one's even worse. This is supposed to be 47. It's reading 1.8. So capacitors are bad. Who made this? Is this a Junzel? Yeah. Junzl. Whatever the heck that is. I'll tell you what it is. It's cheap Chinese-made garbage. So we'll put some Nichicons in there. And we will just... That's a little better, 45. I'll take 45 over 4. Can't have a working power supply if the capacitors aren't working. Kind of important. They need to maintain their original values. Plus or minus, I mean, 20% is, in most cases, 20% is tolerable. If you have a cap that's within 20%, you know, you can get away with it. But when you get past that 20% mark, you better start thinking about replacing. Because once you hit that, you know, you're starting to degrade, and they're not going to get better on their own. Like, they only get worse. So when it's time for a recap, it's time for a recap. Alright. Get this last guy soldered in. No damage through holes. We'll call that a win. We got one more monster that has to go in. We'll get there. Not yet. Not yet. 470 at 200 volts. I'm surprised this used 680s. That's weird. Not a lot of Klipsch amps use 680s in the power supply area anyways. This must be some kind of fancy fancy power supply just for that. I'm just making sure I didn't miss any, and I'm giving the board a once over to make sure nothing looks burnt that I might have missed. I don't want to fire this thing on and have a grenade the second I flip the switch. I don't think it will, but it just doesn't hurt to give it a little eyeball just to make sure everything's there. So yeah, our last big one's going to be a 470 at 200 volt, which I know I have plenty of those. And I'm going to throw a shorty in there because the shorties I have not used in a while. It's a 470 at 200. All right, everything is in. Let's do a little flux residue cleanup. I didn't add any activated flux on there, but I still like to clean up a little bit of the residue that is left. You don't have to, just a quick wipe. Otherwise it gets kind of like crusty. Then the next guy that's working on it will call me a bunch of names and tell me I was lazy. I don't like to use the spray flux removers. I don't think they work nearly as good. Just a little bit of rubbing alcohol, 91%, and a little bit of finger grease, and you get most of the nasty residue off. They don't need to be spotless, just clean. And then, like I said, I'm not using activated flux, so it's really not that critical. It is a no clean that's in the solder. Alright, I need a power supply. Or a power cord, actually, not a power supply. And I might actually take a minute. I am. I'm going to put new ends on these. Some safety ends. JBL 12-inch. I think you worked on the same one. Yeah, anything JBL. 8400Ps are a nightmare to work on. I just submitted an invoice for the last one that I did. Poor guy's been trying to get this amp back forever. Super nice dude. Here's a JBL here. And this one is, pretty much dead. But it was covered in silicone too. I had to dig all the silicone off, but this board has some serious issues. Like the board has actually been burned completely through on both sides. And this is, it's not an 8400, it's a PS 1400. But I know you're paying with the glue. 8400Ps are a nightmare. If the board has holes in it and it's burnt, just throw it out. Don't even bother. That's the best advice I can give you. If it's burnt, throw it out. I am long overdue for putting new crimped ends on this power cord. Gotta make sure we're working safe, so we can take a minute to take a minute safety break. Hey man, I'm glad you're enjoying the videos. If you have any questions, feel free to hit the chat up. I don't always look at it, but if you stick around long enough, I'll answer your question. That's part of the reason why I did this, is because I want people to engage and get into this and maybe do some repairs on their own. It's kind of pointless if I can't, share what I know with other people and help them along. Like I don't really, I don't do it for a business. I wish somebody could tell me why I get all these posts with these links in them. What is VAE.FYI? Does anybody know what the heck that is? These Lyman's pliers are my great-grandfather's pliers, by the way. Love these things. I have a lot of old tools I'm attached to. That's one of them. Alright. So for the 5 people that emailed me telling me my connections were unsafe, they are now safe. And you were right, I needed to do this anyways, so I am not complaining by any stretch of the imagination. Alright. We are hooked up. Let's get this out of the way. Get the other meter and see if we have resurrected this power supply. I'm going to take the crispy cap. We can get rid of that now. I don't think that needs to remain in my cluttered workspace. So we're going to power up, and I know nobody can see this. Yeah, it's got to be propped up. I am still willing to pay somebody to write me a application that allows me to take the serial port here and display the information on the screen. So if one of you are watching this and you're a software nerd, give me an estimate on how much you would charge to write a little Windows app for me. Doesn't need to be fancy. Alright, here we go. We're going to start off current limited and hope we get about 6 to 8 volts on this. Let's see. 7.9. There's 8. We're good. We are in good shape. Power supply has been resurrected. At least part of it. I don't know what the pinout on these is, so we'll have to check it on one of the other boards. But in the meantime, this is good and can go back into his home. And these connectors are going to have to wear in because I can't even unplug them. Maybe I should have left the other ones on there. These things are crazy hard to get off. Alright, I'm going to end up messing up the board. Didn't expect that. Power switch is off, just to be clear. I can't get the connector off. It's stuck. There we go. Hopefully those will wear in with time. Dang. Molex, these are made by Molex. They make good connectors. Alright, let's set this aside. Power supply is good. And bring the beast back. So we have input board. I think we're going to do the input board next, because that looks like it's the easiest one to get to. And unfortunately, since the inputs are directly soldered on there, man, with all these zip ties, they really don't make life easy, do they? Well, zip ties gotta go. I was hoping I would not have to cut all these out and redo them, but No such luck today. Alright. So there is an input board up in the front. There's no caps on that. This is the amplifier board, and this is the preamp slash crossover. Sub EQ select. So I think this is, I don't know what this thing is. It's a stereo amplifier, but it has a sub EQ section with a selector knob on there. I don't really understand this. Well, this must be a subwoofer only amp. So I got speaker outs on it. It's got a left and a right in, but it also has LFE. I don't know, maybe it's a dual, maybe it does both. I don't know. Interesting piece of equipment. Now that can stay. This cable has to go. Volume control. And just to get them out of the way, I am going to take the speaker. Alright. So we're going to do the input board next. My desk is almost not big enough for this. Note to myself, I gotta improve the size of my desk. I'm gonna delete that comment. That I don't understand what it means. Remove. Ibarra O'Neill, sorry person. Your comment did not make any sense to me. So how do we get this out? Looks like we have a couple of switches and 3 screws on the back. 3 screws on the back and 2 screws on the bottom that are threaded into plastic headers. I'm going to try this amp with full range inputs. Try it with full range and with just sub, because I don't know how this thing works. I know how to fix it, but I don't know anything about it. I'm guessing it's a subwoofer only amp. I don't really know why it has 2 channels though. That's I guess I could Google it. It'd probably be the easiest way to figure out what the heck's going on. But either way, it's a nice amp, it's in nice shape, and I'm sure this dude's going to be thrilled when he gets it back. So hopefully we can do a good repair job, keep this thing in the nice shape that it is. So since these wires are soldered in over here, I'm not going to mess with that. I will pull this board out because all I have to do is just take the bar off. Or maybe the whole, I might be able to just get the whole unit out. If I can get the whole unit out, I'll just do that. That might be the better way to do it. But there's not a whole lot of caps on here. There's just some power supply filtering caps. And I believe this capacitor here is for the auto on-off function. There should be some non-polars on here in the audio section. Yeah, we'll get to it. Progress. Trying my best to deal with the bent leads on here. And not damage the board. We're just doing one at a time. Because I don't have schematics for this and I don't want to lose position. So this is 10 UF, 50 volts. Plenty of caps. I have plenty of caps. Hopefully there's no oddball values on here either. Can't really do much if there's some weird cap value and I don't have it. I hope that's not the case. Can the camera see what I'm doing? No. Let's adjust that. There we go. That is a little better. You know, when they design these things, nobody thinks about serviceability. You know, how easy would it have been to just put a couple of fast-on connectors right there? Boop, just plug it in. Be too easy. They don't want you to service it, they want you to throw it out. That one got the finger. Instant second-degree burn. Not much you can do about that, but cry for a second and work through it. It's another reason why I hate these damn bent leads. More prone to cause body injury. Just singed my skin. Yeah, you guys can't see it, but just cooked the first 2 layers of my skin. UF at 50 volts. Another reason why I hate bent cap leads. Right there. They cause injury to my body. Chat disconnected. Uh-oh. Hope my internet's not going down. That would not be good. Says stream still connected though. All right. First 2 are in. Next 2, I'm gonna have to order some more of these 47s. I'm running low on 47s. $47 at 50. And just to be consistent, I want to see if it's a bad batch of caps. Or if just all the 47s are garbage. Well, this one's good. Just the ones on the power supply, for some reason, are no good. But she's gonna sound good. She's gonna perform good. This will be a workhorse when we're done with it. It'll be like a whole new... I'm sure it's going to sound different too. It should sound better. Anytime you replace, you know, junk caps with something good, especially ones in the audio path, you should get a noticeable, you know, increase in the quality of the sound. I mean, it's not always the case. It depends on what part of the circuit it's in, but I'm going to guess that this thing's going to sound better. If nothing else, it'll perform better. Try not to melt my fingertips off again. I have a tip that's one size smaller. I really should be using that tip for these smaller leads because it really makes it easy to hook the end of them and bend them up. It's 100 microfarad at 25. But I don't want to have to cool down the iron and start over, so we'll make do with what we have. Make that 100 at 25. Double checking all my values. So far, so good. And I'm checking to make sure I'm getting good solder flow on both sides of the board too. You know, I want a little bit of a fillet on the top. Maybe where the ground planes are, you know, you won't get it all the way in unless you really pump some heat in there. But it doesn't hurt to check and just make sure you're getting good coverage. Alright, 3 more to go on this board. I'm going to end up burning another one of my fingers tonight, I know it. This lead-free stuff is a joke. That wasn't even the right lead. Helps if you're working on the right leads. Alright. These tiny little microscopic sized caps are hard to work with. It'd be a lot easier if I could get the board out, but I don't really want to unsolder them wires. 10 microfarad, 25 volt. Oh, why is this cap that small? It doesn't need to be that small. What is the reason behind that? This is a normal 10 at 25 volts. And they have this tiny little one wedged in there, and it didn't even fit the space on the board. They had to have the leads like they bent way out. I know you guys probably can't see that, but ridiculous. They save like 3 pennies by using a smaller cap. It's not like the chassis is crowded for space. Alright, 2 more and this board is done. And all we have to do is the amp board. That one, I don't know, it should come out easy. I'm not too worried about it. 100 at 25. Let's test this one. We haven't tested one in a few minutes. I'm just kind of curious if any of the other ones are bad. That one's getting there. Still within 20%, but we will replace it. 25 volts, 100 UF. One more. Another Junzel 220 at 35 volts. That's a new one. I have some. This one is a Rubicon. That's another tier 1 brand. I don't use Rubicons a lot, but sometimes when I need a weird size, they usually have it when Nichicon doesn't. So this one will get a Rubicon. I got a couple of Panasonics and other brand names too. I don't generally use them just for, you know, I use them when I have these like weird applications where you can't find a size, or Sunfire subs are really picky on cap size. There's certain really tight areas that they have them like jammed into and like bent over that it requires a certain can diameter and lead spacing, and not all manufacturers make it, so sometimes you gotta go and deviate a little bit from the norm to make it work. Alright, let's give this board just a quick little wipe down. And we'll be on to the subboard. I think I'm going to put the power supply back in before I pull out the actual amplifier. Not quite sure what was down there, but there was a little residue on there. Somebody was doing something in here. At least it looks like. Maybe that was a factory rework. There's two shiny solder balls though on that film cap. And I didn't do it. Alright, let's get this out of here. And we will pop the preamp board back into its home. And screw it down. If I can remember all the screws that went in there. We had 2 tapered. And 1 of those, and then 2 of these. Put the tapered ones in on the bottom first because they're going to be the most difficult. All right. Let's see, we're hour 30 in. Not too bad. Not too bad. Especially for never have done one of these before. Never having done one of these before? I don't know. I don't know what the proper verbiage is. I guess the screws sit just a tiny bit proud on the surface. Not much you can do about that. And I apologize that you can't see me driving the screws in here, but I don't think that's gonna make or break the video. If it does, you know, yell at me and I'll move the camera. But just a little bit of reassembly before I take the rest of it apart and have screws littered all over my workbench here. Okay, that is back in. Let's get our power supply started back in. Since it is freshly resurrected. Those are the case screws. I need 2, 3 screws. There we go. This one had 3 screws that went into standoffs and 3 screws that went into plastic. See if I can get one of these started without this thing flying away on me. These are not going to be easy to get in. Not without an extra set of hands or some black magic or voodoo magic or whatever the hell you want to call it. Not easy to defy gravity while you're trying to hold something in place and turn a screwdriver at the same time. Especially when you're dealing with screws that are not even a 1/4 inch long. If you have fat fingers, forget about it. I'm just going to snug the screws down. We're not going to make them tight. They don't need to be super tight, just snug. We're not trying to strip them out. Another one of them stupid comments. I need to find somebody that speaks Russian that can tell me what the hell's going on with them comments. Drives me nuts. I should just email another streamer and ask them if they get those issues. People just spamming links and stuff in their chat. Alright, this is the part that's never fun. Screwing in the plastic standoffs because they always want to turn on you. I admit defeat. These standoffs have beat me. At least for now. Once the pliers come out, I will be victorious. If I can find my pliers. There's cutters, there's more cutters, here's my pliers. They are hiding from me. At least the screws are nice and tight though. Okay. Last screw. Power supply is home. Now we gotta take out the amp board. Let's do a little maintenance here and hook in our wires. On Klipsch they use red for line. I don't know why they do that. Black is almost always line and neutral should be white. They use red. I don't really agree with that, but that's what they do. Alright, so we can hook up our speaker outputs now, plus and minus. These are our power inputs. Actually, no, I don't know why I did that. That was really dumb. I need to take that board out, and I'm connecting things to it. I can connect things to here, to the input board. And I can connect my power wires to the power supply, but the amp needs to come back out. And then we got to re-zip tie this. There were 3 zip ties on here. We'll tidy it up and make it look nice. I can see kind of where the zip ties went. One here, here, and one over here somewhere. Alright, let's disconnect everything over here. Again, some of these have locking things on them, so if you're working on one of these amps, don't just try to rip the connectors out, because you will do damage. You got to use a little pick. Push the little button in. When you do that, it comes right out. These ones I made sure to rotate them so the button is facing me. That one I'm not going to worry about. Alright. So the amp looks to be in good condition, the amp board. So I think I'm going to leave the heatsink on and just take the whole module out. That way I avoid getting the white thermal paste all over me. And if any of you have watched my videos, you know how much I hate white thermal paste. It's good when you need it, but it just makes it a mess everywhere. So I am going to remove the whole unit, or attempt to remove the whole unit, which I think I can do. That was great. There it is. One monster heatsink. And one amplifier board. So yeah, just for the heck of it, I'm digging into my graveyard here. Because I'm curious more than anything, because I've never worked on one of these before. You know, it's a little bit different. Not much, but I've seen boards very similar to this. This is out of an RW10, I believe, 10 or 10D. I've seen this board before though. I want to say it was like in an RSW series maybe. I don't know. I've seen it. Where? I can't exactly remember. I don't think I've ever seen it with 6 output transistors though. So we're going to carefully recap this without hopefully burning any fingers. And then we're going to throw this thing back together and fire it up. So since this is the audio section, we're getting into the non-polar caps now. And I hope I have all of them. This is 2.2 at 50. I have that one. .2 at 50. Polarity generally doesn't matter, but I always try to put the longer lead in the more positive side. I don't know if it makes a difference or not. Some people say it does, some people say it doesn't. I think on subwoofers it matters less. Leaving that heatsink on was a fantastic idea. Makes a really nice kickstand for working on this. Doesn't quite stand up, but it's alright, I can still get in there. That's the most important part. Can I get in there? Alright, 22 microfarad bipolar 50 volts. I have that one too. And we're lucking out tonight. And I'm just throwing all Nichicons in there. That's what I have. But it should sound pretty darn good with these in there. I mean, just having fresh caps in there by itself is enough to make a difference. But when you're replacing cheap junk with quality parts, that's when you really get you know, the most gains out of it. Here we go. Next cap. I gotta fix my wire here. My microphone wire is in my way. Alright, this is a power supply filter cap. 100 microfarad, 25 volts. Uh-oh. I think this is the only polarized cap on the board here. Alright, putting that wire behind me was a mistake. I wish I could go to a wireless headset again, but I've had too many videos where the battery dies or something goes wrong, like right into the middle of the stream. And I just don't have the time to go back over and like voice narrate the videos, so that information's like kind of lost forever. So I stick with wired, unfortunately, because it doesn't go, it doesn't fail. Batteries don't die. But the problem is I have a wire in my way when I'm trying to pull a cap out. So I am using the tip to try and straighten the leads out a little bit. Just gotta kind of be careful because you can damage the board that way. .250 bipolar. And I'm not going to bother measuring any of these. The bipolar caps are usually good. I don't generally have a lot of issues with those. Every once in a while you'll find one that's not good anymore, but they're real easy to find if they're in the audio path because you just measure the audio signal until you can't find the signal anymore, and whatever cap it stops at is the one you generally have to replace. I'm going to say that the only issue with this was the power supply, but we're going to go ahead and recap it all anyways, just because there weren't that many caps in it, and the amount that I found bad lead me to believe that it was time for this to get a recap. .22 at 50 volts. These guys are much bigger than the ones that I had in there. I don't know who makes these. It's a different brand. I can't really read the logo on there. IG. Still probably an off-brand, knockoff brand. We do have some room on the bottom of this board too if, we get too tight and we can't fit a cap in there, but I don't think I need to do that right now, but you could always lay one down and solder it in from the other side if you had to. This one here it's a little big and it's touching the edge of the shell right here where the LED goes, but that's really not a problem. I could probably fix the camera and zoom in a little more too. Alright, one more. We did these two. Yeah, we did those. Just one more. One more, and looks like it's going to be a 4.7 bipolar. So I think the main failure of this amp was it either ran really hot and the film capacitor started to deteriorate, or it took some sort of surge or spike, and that surge or spike knocked out the film caps, but at the same time some of the 47 microfarad polarized caps were way out out of tolerance. I think the worst one reading only 1.8 out of 47. I mean, that's really low. That's the wrong value. .7, 35 volt. There we go. Non-polar, right? Looks like non-polar. There's no polarization markings on it, so it's getting a non-polar. And the board is not marked for polar anyways. That should be it. That should be all we need to bring this bad boy back to life. Trim the leads. Give the board a little wipe down just to get some of the flux off. And we will get this back in there. I'll clean up this mess on here and we'll test it out. See what it looks like on the oscilloscope. So we are a few minutes away from testing. I'm glad I got the opportunity to actually work on this and make a video of working on it. It's a win-win because I've never worked on one of these before. Now I can say I have when I'm at least a little familiar with them. There's not a whole lot new or different about these than really any of the other Klipsch bash style amps I've worked on, so that's kind of reassuring, I guess. My limited knowledge is still applicable on some of their different gear, not just subwoofers. I know I have one of the people on my waiting list has, I'm sure more than one, has some amplified floor speakers that he says is having some issues, so I'd be curious to see if it uses the same bash amp. Alright. Let's I'm just gonna recycle all these caps here real quick. I need to get a bigger box. Clean up my mat and then I will bring the amplifier back down. Film caps are garbage. Don't want to lose these screws. Those are kind of important. I need those. There should be 3 of them. I only see 2. Hope I didn't drop one. It's gotta be here somewhere. They can run, but they cannot go too far. Unless I legitimate did throw it in the cap box or the garbage. Then it did go too far. If anybody was watching the video, tell me I didn't throw that cap in, or that screw in the cap, in my cap garbage box. That would suck. Alright, where is screw number 3? That is not it. Totally just lost a screw that was sitting right in front of me. I'm losing my mind tonight. I'm losing it. Hold on, maybe it's in the amp. Let's grab this. Yep, there it is. I found it. It was hiding inside the chassis. That's good, because if I would have dropped it in the cap box, that would have been a mess. Alright, let's get this bad boy screwed back in and get him ready to make some noise. Not too much noise, though. I don't want to get yelled at. I'm sure you married folks out there understand. Subwoofer at 1 in the morning might get the wife a little excited. Luckily we have 300 watts of silent speaker that we can test. And we can go up to, you know, some higher wattages too, just not for a long time. We put 900 watts into it last night for a few minutes and it survived just fine. If you know, anybody's interested, on January 23rd I made a video of a Velodyne repair, and it was a 750 watt amp, but man, that thing really puts out some power. 750 RMS. I was quite impressed by it. And I've worked on a ton of Velodyne equipment. I have a whole bunch of it. I just did not know that their smaller amps could put out, you know, the serious power levels like that. I mean, I guess in the grand scheme of things, it's not really serious power, but it's nothing to joke around about either. Alright, let's get our wires hooked back up. We'll start with our power. I'm going to lightly twist these together. When you have power wires and you twist them, it just kind of helps reduce the noise a little bit. Any noise that they might emit. It's kind of a weak twist job, but better than nothing. This guy, I believe, went behind those. Just want to get everything in, make it look halfway decent, like it did from the factory. Interesting enough, this doesn't have an LED to plug into that board, so this board is used in other places. I can confirm that now just by... You know what? I'm gonna move this again. This guy's not gonna get zip tied this time. He's just gonna go like that. Well, maybe I will zip tie him. Alright, speaker outputs, those don't really need to be twisted. Just need to make sure they're in the right spot. Positive, negative. Alright, everything's hooked up. I know we need a fuse in here. There is a spare in the housing. It's not in the correct spot though, so I'm going to check the value, and if it's the right one, put it in the right spot. 6.3. So I will snap him in and throw it in there. This thing should never blow any fuses. If it's blowing fuses, something is seriously wrong. Alright. Moment of truth. I don't even know how to set this thing up on here. I do need a power cord. I threw my power cord out the other day because it started to fray and it was not safe. So give me a second, let me grab a power cord and I will be right back. All my power cords are extremely heavy duty and overkill for these. I had a nice small thin one that was like super flexible, but it started to fray and I just cut the end of it off and said, you know what, I'm not going to deal with it. Okay, so we have juice going in, our power switch is turned on. Everything appears to be hooked up right. CD minus is black. Just make sure everything's plugged into the right spot. If you cross CD plus and CD minus, the amp will probably go up in flames. You will definitely burn something out, so. Alright, I think we're in good shape. The only thing that sucks is I'm going to have to unplug the speakers because I won't have a way to plug in. So I don't have anything that'll go to posts. So I'm going to pull those out and I will just take my regular woofer. Now I'll show you guys what it looks like on the scope. I just want to make sure I get some audio out of here first. I want to hear it. And then after I hear it, I will hook it up to the silent speaker in the scope. I'm making sure volume's all the way down, crossover's all the way up. I'm not going to mess with any of his settings back here. I don't really know what the sub EQ selector does. I guess there's like probably some built-in crossover points. They give you a choice of 4 different points. I'm just going to go into the LF. You know what? Actually, I'm going to just do this. That's mono anyways. I'm going to go into LFE. So I have my speaker hooked up. Let's turn off my irons. I don't need that anymore. We can zoom out a little bit on the camera so you guys can actually see what's happening here. Somewhat. Let's turn on my signal generator. We're at 40 hertz. Alright, current limited we're going to start at. Let's see what happens. Power supply came on, that's a good sign. We have green power light in the front, that's good. Let's give it a little volume. Ooh, it sounds good. I know you guys can't hear that, but I can hear it. It sounds good. Let's dial the frequency down. 30 hertz. Oh yeah, alright. I'm going to kill the power. And disconnect the speaker. And what I will do is connect the silent speaker. Polarity doesn't really matter. And The nice thing about silent speaker is you can't hear it, but you can see it. And that is equally as important. So, as long as my battery isn't completely dead, everybody will be able to see what's going on in here. So we're gonna go current limited again. Ooh, didn't like that. Alright, I guess we gotta go to full power. 4 ohms is a little bit too much of a load. This thing's a little touchy. So you can see I'm putting 30 hertz into it. It's measuring 31. If I speed up the sampling time, it starts to get a little more accurate, but it makes it a little harder to see, so I like to spread it out. Make sure you guys can see the full waveform. Let's crank it up to 5 volts per division. So let's give it some volume. So we're at 10 volts RMS roughly. It's got a really nice clean sine wave. Let's see what we're putting out in power on this, just so I could update everybody as I crank out the volume levels. It's just Ohm's law, basically, but I don't feel like doing math in my head. So we got 10 volts RMS. Our resistance is 4 ohms. So we're at about 25 watts right now. So at 20 volts, I think we should be at 50 watts, right? No, because it's power is what I squared R. So 100 watts. So let's see how high our voltage actually gets on here. So 17, 20, 25, 30, 40. Alright, something's getting hot. So our inrush current limiter was getting a little hot. But we got way up there in the voltage. And those do get hot under normal operation. Just for the hell of it, let's see what we're at 40 volts. I don't know if this amp is 4 ohm stable. Probably not. Yeah, 40 volts, it's 400 watts. 50 volts, it's 625. So my load's only rated for 300. So let's see where we got to take the voltage to get to 300. $34. So if we stay under 30, we should be okay, and I won't burn anything on my testing gear up. But I mean, this thing is screaming. And I know it went up to 50 because I was watching my voltage on there, so you know, we definitely exceeded the 500 watts. I'm sure there's, you know, this will do a different value at peak output, so. But I don't want to overstress the amp. Like a pure sine wave almost never happens in audio, and if it does, it's only for, you know, short duration. So I mean, when you're giving it a signal like that, I mean, you're really working the amp hard. Peak to peak voltage right now we're seeing 41 volts, but our resistors are getting warm, not hot. But what I'm looking for is I'm looking at the sine wave, and I'm looking for anomalies in there. I'm looking for distortion. I'm looking to see if, you know, if it starts fluttering, if it starts dancing around, if it starts doing something weird. I'm not really interested in peak output. Yeah, I mean, yeah, I can crank this up until this thing's like glowing red hot, but all I'm gonna do is just stress the components and damage it. So I'm more interested in, is it functioning? You know, does it tolerate the load? And then just for the hell of it, let's look it up. Let's see what this thing is rated for. Is it rated for 4 ohms? Probably not. I'm sure I can find a spec sheet on this really quick. There we go. It's got an EQ switch for use with different subwoofers. 300 watts into 8 ohms or 500 into 4 ohms. Okay, so it will do 500 and 4 ohms. It's rated for it. Interesting. So let's see what we got to do to get it up to that 500 watts. How many volts is that going to be? .44. So if we take it up to 44 volts, we should get up to 500. Volume's at about a quarter of the level right now. Let's 20 is as low as this little scope will go. That NTC is getting hot. It's smoking a little bit. I'm going to have to check that part and make sure it's not damaged. It doesn't look to be damaged, but it doesn't like those higher outputs either. I mean, I don't know. That just could be because it had this amp hasn't been worked that hard. But I don't know how many amps that's rated for. I don't know what I'm drawing either right now. It hasn't cleared the fuse yet though, so we're in the specs. But again, you know, drawing a pure sine wave on an amp is really hard on it. This thing just chugs away. It gets hot, but it just chugs away. Pretty nice amp. It's a terrible misuse of the box in here, but other than that, it's still a pretty nice amp. I'm going to let it continue to cook for a while. The outputs are barely warm. You know, if this thing's, you know, turned on and, you know, you're trying to do some work in there, you definitely don't want to touch more than one metal part at a time. You really shouldn't touch any, but I'm just checking the heat sinks. But you never want to check, you know, 2 heat sinks that are across from one another. Just do one at a time if you're checking for heat. And the reason is there could be a voltage difference between the two, and you don't want to burn yourself. So the power supply is running warm, but I would say it's well within rated specs. The output looks really good. Again, going into a 4 ohm load, you know, puts a lot of stress on the amplifier. It's rated for 4 ohms, 500 watts. I did not see if that was continuous. And it does say 500 watts continuous into 4 ohms. So it should be able to handle it. So let's crank it back up. Let's see what happens. I'm interested to see if the NTC blows. I'm checking the dial bridge too. The dial bridge it's warm. It's not as hot as the thermistor here. That guy is hot. I mean, they're rated to get hot though, so I'm going to keep letting this thing cook. It seems to be handling it okay. I'm looking at the waveform. The waveform is behaving. Nothing yet, so we're going to keep testing it. I'm going to, monitor the temperatures and make sure the temperatures aren't being exceeded, because there is no active cooling on here. I mean, the input power side is cool as a cucumber. I'll put it on the DC side. It's a little warm. It's not out of spec. It's just warm. Regular output, they're starting to heat up a little bit. Going into 4 ohms, I mean, you're gonna put out some heat. Another stupid comment. Sorry, Lawson. I don't know what you were linking in there, but I don't want links in my chat. So again, we're keeping an eye on the waveform, and I'm just making sure that the waveform is not going to be distorted. And we're still at 30 hertz. And I'm going to look up some power calculations just to make sure that I'm doing this right. I don't know if I should be looking at the RMS voltage, or if I should be looking at peak to peak. Okay, so if I use the RMS voltage, I get real watts. If I use the peak voltage, that gives me the peak output. Alright. Let's crank up the RMS. So we're at 30 volts RMS right now. Which means that my resistors are probably screaming hot. No, 30 volts is 225 watts, so that's good. So we're going to let it sit right there. 225 RMS. That's a good temperature to bake this at. And again, I'm not looking to thermally, stress it. I'm just looking for problems to arise. The replacement capacitors are going to need time to form, so you're going to have to get some hours on this before the sound is, truly dialed in. But I'm just looking for anything that looks like out of the norm. So, is something getting excessively hot? Is that going to cause damage? Things like that. Is this inrush limiter, bad? Usually when they're bad, you can see a mark on them. I have plenty of replacements. I don't know what that one's rated for, but it should be rated for at least 6 amps. I have some 4 ohm, 10 ohm, a bunch of different ones. 10 ohm 4 amps is generally what Klipsch uses. I'm not sure what they use on this guy. I can't really see the numbers. There might not even be any numbers on it. None that I see. They're probably burned off. Power supply is good and hot right now. Input side is starting to get hot. Voltage regulators are always hot. Amp side is starting to heat up pretty good too. So this is what we wanted. I wanted to get some heat through it. I wanted to make sure that, you know, nothing is going to go wrong because of it heating up. The sine wave, you know, even on this cheap meter, the sine wave looks pretty stable. And I mean, you'll see like little tiny deflections and things, but that what I've learned is it's not because of the amp, it's because of the cheap scope. You know, I have a really good scope on the bench that I could hook it up to and watch it. You guys won't be able to see it, so that doesn't really help. So I prefer to use the cheap little battery scope. Plus, the nice thing about this being battery is it's 100% isolated, so I don't have to worry about blowing it up, blowing a channel. The power source is inside the box, so it's nice to know that the scope is isolated and I don't have to worry about it. But you know, 50% duty cycle on a sine wave, 30 hertz, 225 watts. I'm going to say that this thing is just fine. And we're going into a 4 ohm load, so in real world, you know, the amp never sees a load like this. You're never going to see a monotone audio signal like that long. You know, generally this is going to see bass hits and there's going to be some gap in between the different frequencies, so, and they're not going to all be the same. They'll be high frequency, low frequency. So at 225 watts it'll never run this hot in real use. Hey Connor, what's up, man? Yeah, I've never seen one of these either before today. It's a standalone subwoofer amp. It's still a bash amp. It uses a lot of the same, you know, circuit design as other bash amps. Like this is the 1000-watt bigger brother of this guy. This is a 500 watt. The 1000-watt has 4 transistors on the input side, but I mean it's almost an identical design. I checked out the email, but I never really dived into them yet. I haven't had time, but I appreciate you sending those out. I have a couple of JBLs and some other stuff that I got to get into before I get to another Velodyne, but I will definitely check them out. I will say that this amp does not put out nearly as much power as that Velodyne amp does, which is kind of crazy. A plate amp half this size and it just destroys this amp. I mean, this isn't a bad amp, but she does get a little hot when you crank the power up. Let's see what we need to get to 300 watts. I think it's going to be like 35 volts. .6. I was close. So my load resistors are screaming hot. I could heat. Oh yeah, I can't even touch them. Could heat my coffee up on them. I gotta worry about melting the screws. Let's just take it up to full 300. Make sure nothing smokes. No, everything looks good. Everything looks real good. She's running hot, but she's running well. I'm going to dial it back down a little bit because I just need to let everything cool off a little bit. This thing is screaming. But I think we've restored this amp. So let me grab my little insulated stick here, and we can poke around and go over what we saw. So first thing I noticed was we had, let's move this. We can put it over here. You guys can still see that, I think. Maybe. We had a Carly cap fail, which is common. Either power surge or heat cause that to fail. This heatsink does, I mean, it's warm now. Yeah, I actually can't leave my fingers on it. It's too hot to leave my fingers on. But cap failure. We had the electrolytic here that was out of tolerance. We had 2 electrolytics over here that were out of tolerance. I didn't check. I don't think I checked any of these. So at least 3 bad caps. At least 4 bad caps. 1 film, 2 electrolytics. I did the 2 other Carlys on this side of the supply just because, you know, if you're going to do one, you might as well do them all. These ones generally don't fail. The inrush limiter does not appear to be damaged. Now that I'm in here, I can kind of take a peek at it a little better. I don't want to stick my fingers in there because they'll burn me. I do not see any burns or markings on that. Usually when they go bad, you'll see a burned hole going right through the side of them. It's really noticeable. There's no writing on these, so I don't know what they are. If I had to guess, though, I would probably just do, well, here, I'll tell you what I would do. I would do the same one that this guy has, which is also unlabeled. Or I might be, you know, it might be labeled, but it's hard to read. Yeah, this says 500 watts into 4 ohms, and it does do 500 watts into 4 ohms, but I don't think it's rated for like 500 watts of like pure sine wave. Maybe it is, but I'm not going to drive it that hard. I mean, this thing it's heating up. We did about 300 watts, and let's see, I got a little bit of smoke coming out of the inrush limiter, but that could have just been, you know, because it was never brought up to that high of a temperature, and you know, this is just ceramic, so sometimes it does absorb a little bit of moisture. The fuse wasn't cleared. It might have been cleared when the cap blew, but I don't see any other signs of damage. So I'm pretty sure this guy's good. I don't see any burn marks on there. I should, let me get my flashlight out and take a look just for the heck of it. That way I can verify. And of course my phone's only at 3%, so the flashlight's not going to turn on. You know, I looked on the serial number. I can't find a date. The serial number is the model number, and then the first 2 digits are 1218 and then 01. So I don't think it's from 2018. So it's either 2001 or 2012 would be my guess. Not that old though. I mean, it's in pretty nice shape. But these types of amp boards, and actually I have another one. So while this thing is continuously cooking, I'm gonna go grab one of the other ones. I'm kind of, I want to know what the value of that inrush limiter is. There we go. That should look a little familiar. So I was definitely right about this being used in multiple different versions and configurations. This is just a parts plate that I have. I don't have the rest of the plate. But you can see all the little circuits and stuff are not populated in there for the auxiliary board. I don't know what that board does. It's got something to do with the preamp section. I'm guessing power supplies or something. I don't know. I don't have a schematic. But this is the 500 watt amp out of a standard subwoofer, and this is the one that's in the standalone amp. It's the same exact thing. Like even the caps, you know, the tank caps, 680s, 470. So these are interchangeable. Like if I had to, I could take all those little components out of there, populate them onto this board, and it would be up and running. Even the part number on the board's the same. This is a Rev 5, this is a Rev 1. So this one's a little bit older, but still somewhat interchangeable. But what I want to find out is this guy here, and what this value is. And this says DSP056. And I have a conversion sheet for those because a long time ago I looked it up. So let's find out what that really is. Yeah, that could be part of the on-off related circuit. I know the big one, this one has a legit on-off on it. That's what this board is here. This is a standby circuit, and when it shuts off, it actually does power the full sub off. Let's find out what our value is for that inrush limiter. It's going to drive me nuts unless I look it up. Plus somebody might need that information, so my little secret folder of all my stuff. I found this on a website a long time ago, and I printed it out, and I've never been able to find it again, but it's like a list of all those DSPs on there. So it goes by the diameter of it, so that looks like it's either 13 or 15, and it's an 056. So it's got to be a 15. So it's 6 amps. Rated 0. So it's 5 ohms, 6 amps is what that device is. Inrush current limiter. Which if you look at the sheet, it's actually a little bit undersized. The fuse in this system is 6.3 amps. Just for theoretical science and math, let's see what we'd be actually working with here. So if we have 6 amps, 120 volts, that's so absolute maximum peak is 720. So I guess that's within tolerances. The 6 amps is just a fault condition. I should hook my portawatts up to this thing and see what we're actually pulling through it. I wonder if I have that upstairs. Just because I'm kind of curious. Especially I'd like to know what I'm drawing that would make that thing potentially smoke. I got a couple people hanging out, so yeah, if you guys want to stick around for a minute, I'm going to go up and get the portawatts and have a look at what I'm actually drawing out of this thing. I will be back in a minute. Hey, thanks for telling me. I'm just like talking to myself like an idiot over here and nobody can hear what I have to say. Um, what I'm doing is I'm keeping an eye on the amps that I'm pulling out of the wall, and I'm looking at how many volts RMS I have on my meter here. So 30 volts is about 225 watts. 34 volts is 300. But if I take this up to 34, I'm still within limit. I'm at 5.6 amps, which is getting real close to the limit of the inrush limiter. So at 300 watts, this is starting to become, at least the power supply is starting to become peaked. The kilowatt says I'm at 5.2 amps, 425 watts. But this inrush limiter here is only rated for 6 amps, and the fuse is only 6.3. So I don't want to pop the fuse. But I'm still not even at 50% volume. So part of that is because we're giving it a pure sine wave load. There's really no break, so it's pushing the amp really hard. If I went up in frequency, it would sort of tame down a little bit. Like if I took this up to 60 hertz, my current drug dropped all the way down to 1.7 amps. So, I mean, now I can crank it. I mean, I'm at like almost 75% and I'm still not hitting 5 amps. So, you know, a 30 hertz load is a significant load going into any amp, really. It doesn't really have to be a dedicated subwoofer amp, but I like to test at 30 just because it is kind of a, you know, a stressing point, and I like the way 30 hertz sound. 34 hertz is kind of like a pleasing sound to me. I don't know why. We can check our crossover, make sure our crossover is behaving. It's doing absolutely nothing. Granted, we're okay, so that crossover starts at 40. Let's crank this back up to 60 hertz. Let's see if I cross it over, if it does anything. Interesting. It's doing absolutely nothing. I don't know exactly what this knob is supposed to do. I would think it would attenuate the sound. Oh, so I'm in the LFE port. I bet that LFE is probably plus 10 dB and direct if it follows audio standard. So the crossover probably doesn't work. The crossover probably only works if I go into LR. So let's try that. Turn our volume down. Let's hit L and R. Good test of the ports anyways to make sure they're working. Alright, yeah, so the crossover works in LR. LFE is uncrossed, that's good to know. Yeah, super nice amp. I don't understand why they put it in such a big chassis though. Like you could fit 2 of these easily in here. Probably 3 if you did it right. But it uses a standard subwoofer power supply, a standard subwoofer amplifier board, and the only thing unique to this is this preamp board. I have not seen one of those preamp boards, but I mean, it's up and running. It's running good. The output looks nice and clean. It's definitely putting out the juice. Oop, gotta turn it down. We were at 8 amps there for a minute. I do have a slow blow fuse in there, but I don't want to blow the fuse. She's good and hot. I mean, the output heatsink is getting warm. The power supply is definitely toasty. This is the DC switching side for the mains. This is the plus minus 15 volt, and this is the switching side for the transformer. And, I mean, this power supply is screaming hot now. The outputs are nice and toasty, so we're at a good operating temperature, and everything seems to be holding up. Gotta stay under 6 amps though. If you exceed 6 amps, you're eventually going to burn out the inrush limiters. Again, 30 hertz, is not normal operating conditions, so you're going to see exceeded values when you're working off of a set frequency. I wouldn't be too concerned over that. Even getting the plate hot, I'm not worried about that. As long as I'm not seeing any, degradation in the output waveform, I'm not going to be concerned with it. I'm just concerned with heat. I don't want you don't want the capacitors getting too hot, and I'm feeling them. Don't touch both tops at the same time. Shouldn't even really be touching them. I just want to make sure that I'm not getting too hot. This heat will definitely kill capacitors. Now these are rated for 105C, which is pretty damn hot, but still something that should be checked and monitored. A better design would be to have a fan in here cooling this. It's something that could even be added if you really needed to, but I mean, they must have figured it out at the factory that it wasn't needed. Here's something I find kind of interesting too. It's hard to see on the camera, but I don't know if you can see that mark there and this mark here. This amp had a couple of scratches in it, and somebody took a Sharpie and colored them in. I don't know if that was a factory thing or if the owner did that. But the Sharpie black ink turns like a purplish blue after it dries. Yeah, I do have a thermal cam. It's at work right now, unfortunately, which doesn't do me much good. But I explained earlier, as long as you don't touch two things at the same time, you're all right. So, like, if you're going to check the high voltage side, just grab that one. You don't want to touch more than one thing at the same time. Never with both your hands either. I keep one hand in my lap, and my other hand is my probing hand. So far, so good. I'm going to say this is probably ready to be shut down and buttoned up. We're doing 26 volts, so we're probably a little bit over 200 watts, close to 200 watts. My silent speaker is cooking itself quite nicely. Hopefully it's not hot enough to melt my wires. Yep, it's melting my wires. It melted them. Damn it. Well, lesson learned. We're going to have to go silicone on the pure silicone on the silent speaker wires. It totally just melted them right to the side of the resistor too. That's gonna stink. I gotta get that cleaned off, damn it. I just melt my probe too. Whole place is coming down. It's alright. I'm happy it's out of the way. And I should have been smart enough to use silicone wires to begin with. I have a ton of silicone wire. Rookie mistake. But, alright, well, I am going to dial this down now. I am happy with the way that it's performing. I think the owner's going to be happy with the way it's performing. We got it good and hot. We verified that everything is working. The input's working. The controls are all working. We tested it with the speaker earlier. It had really nice sound. We looked at the sound on the scope. The waveform looks good. So I think we're in pretty good shape. So I'm going to go ahead and call this one done. I'm going to get it unhooked up, kill the power, fix my melted wires, and oh yeah, there you can see it now. This is where I move my silent speaker to. I can give you a little bench tour. So this is my extremely hot transformer that I use to drain caps. It's you can use anything. You can use a light bulb. You can use anything. You just need something to take the voltage hit from the caps. I just use a Pro Media 2.1 transformer because I had one laying around, and just hot wired a couple of really cheap scope probes into it. And then yeah, this is my 300 watt silent speaker. It's two 300 watt 8 ohm resistors in parallel, so it gives me 4 ohms 300 watts. Actually 4 ohms 600 watts, but they get too freaking hot when you go even above 300. Like, I can't even touch these really. They will burn me. But that is how I test the amp and keep the wife from killing me. But I appreciate, anybody tuning in. If you have any questions, please post them in the comments. Please subscribe and like the videos. That always helps. This actually is a space heater. It's putting out a ton of heat right now. I can barely touch this. Like, my transformer's getting hot from it. I should put a little fan on there. I could heat this room up. That's not a bad idea. But then in the summertime, I'll hate it because it'll be a bazillion degrees down here. But no, please remember, like and subscribe. If you have any requests for like an amp or plate you'd like to see me repair, let me know in the comments. If I have it or if I can find one, I'll get to it. I think this week I have 2 JBLs coming up, and whatever's in that box over there. I think it's a Sunfire HRS 12. It's Sunfire HRS 12 and 2 JBLs. So those will be coming up sometime this week. I don't know when. I'm going to try and get on tomorrow. I just can't promise that I'll be able to do it. So if I have some free time, I'll be here, and we'll get the next batch of amps done and repaired. So thanks for tuning in for tonight. I'm going to call it a night, and hopefully I will see you guys tomorrow or soon. Thanks for tuning in.